Okay, we're going to write this quadratic function in vertex form. That's the type of form that it wants it in. So if I'm writing this in vertex form, what I'm going to do, I'm going to have to arrange some things here. First of all, this negative 45 that's at the end here, I'm going to basically just pretend it doesn't exist for the first few steps of this problem. So we'll change it to, first, I guess, along with that, we're going to take out a negative 3 out of the first two terms. I can see that I can take a negative 3 out of 24. So, and I also just want to get that x by itself because it's by itself when it's in vertex form. So if I pull out a negative 3, that leaves me with x squared. And then if we pull out a negative 3 out of 24, that's negative 8 left over. And then I'm going to leave some space here. I'll show you what I'm going to do in a second with that. And then I'm going to put negative 45 at the back. That's the setup to this question. So really, all I've done, it just looks weird. All I've done is taken a negative 3 out of the first two terms so far, and then I left a little bit of extra space in there. That space I'm going to fill with basically b divided by 2 squared. That's what you're going to use to fill in that space for all of these problems. My b value is a negative 8. I'm taking this current b value, which is negative 8. And I'm going to divide it by 2, which makes negative 4. I'm going to square it. That makes 16. And now I've just added something to one side of my equation. I can't add something to one side of an equation, otherwise it's not balanced. So I actually need to subtract it from the same side because I'm not going to add it to the other side. There's an f of x over there. But if I subtract it from this equation, then it's like nothing ever happened. Now I know that I added a 16 in there, but that 16 is really being multiplied by negative 3 out front. So really what I just added would be negative 3 times 16. Well, negative 3 times 16 is 48, or negative 48. And I'm going to stick that negative 48 on the back end. Okay, so let's see what we have now. That negative 3, I'm just going to leave it there. I'm going to factor this equation. I chose this on purpose because now when I factor, I'm going to get the same thing twice. I'll get, negative 4 and negative 4. X minus 4 and x minus 4. So that means I have x minus 4 squared. And then negative 45 and negative 48, if I add those together, I'd get negative 93. And that's it. That's how you rearrange this equation to put it in vertex form. It's kind of complicated. You got to separate some things and move things around, but it's not that bad once you get the hang of it. Topic 13. Topic 13, we're going to answer the questions below about the quadratic equation. Does the function have a minimum or a maximum value? Since I see my a value is negative, I know that it's going to be pointing down. That's what the a value shows us. So this is going to have a maximum because that point up there would be the maximum of that parabola. What is the function's minimum or maximum value? To do that, I need to find that number. I'm actually just going to take us onto our graphing calculator because this will be a lot easier with a graphing calculator. I'll use Desmos here. You would use your calculator that you have in class. Negative 2, negative 8, and negative 11 are my three terms. Negative 2, negative 2x squared. I've already forgotten. Negative 8 and negative 11. Okay, I got to zoom out a little bit to see this graph. There it is. It's pointing down just like we said. Our vertex is located at negative 2, negative 3. So I guess when we're talking about the function's minimum or maximum value, that's our y value. So that would be the negative 3. It says where does it occur? X would equal negative 2. So yeah. Last topic, I'm going to have to use the graphing calculator for this one as well. It says an aircraft factory manufactures airplane engines. The unit cost C, the cost in dollars to make each airplane engine, depends on the number of engines made. If X engines are made, then the cost given by the function equals that. What's the minimum unit cost? So this isn't a very well-known thing, but actually parabolas come in handy in business because you can figure out how sales affect income by using parabolas. So I'm going to write this in. So negative, or sorry, 0.8, it was. And then it was negative 144. And then 22751 was plus. Okay, that's our function. I don't see the graph. I'm going to have to zoom out a little bit. Oh, where is it? Shoot. This is going to be pretty far out. So let's see. I can find my y-intercept. I know where that's located, unless I type something in wrong here. Do I need... $22, 7. I still don't see it. Maybe something's typed in wrong. That's 144. It's 22,751. Maybe I need a y equals in front. I don't know. I'm a little stumped on why it's not showing up now. Because it should be up there. Oh, shoot. Well, I guess there's another way to do this. Maybe it's the better way to do it anyway. Let's just go through it the other way. So the best way to do this we're trying to find the vertex. I thought I could pretty easily just find it on a graph, but there is an easier way. We could just do the negative b over 2a like we've done before. And this one we won't have to search a graph to find it. So negative b divided by 2a would be 144. Oops. 144 divided by, it's going to be 1.6. So 144 divided by 1.6 equals 90. And if I plug that back in, let's see, we'll have, oof, this is tough on a phone calculator. Let me grab a different one. 0.8 times 90 squared minus 144 times 90 plus 22751. I got 16,200. Oh, this is, sorry about that. I have 16,271. So that's my vertex. I might go back onto Desmos later and see if I can find that, but I don't know why it wasn't showing up. That's my vertex. And yeah, so basically what that's saying is my minimum unit cost, if you think about it, my parabola is going to be like this. This point would be at the very, very bottom of that parabola. My minimum cost is going to be basically the height, because the unit cost C was like my Y value. So the minimum cost would be the Y value as well. X was the number of engines that were made. So that's going to be my X value. So at 90 engines, the minimum cost was 16,271. That's the way I would go about that problem, I guess. It might be even a little bit easier than using a graphic calculator.